Hello, welcome to our session. We're going to talk today about reducing downtime for SAP workloads on Azure with SLES. The agenda for today, first Sherry will cover the topic of SUSE Microsoft partnership. Then we're going to talk what benefits high availability brings for you. We're going to talk about methods to reduce both planned and unplanned downtime. We'll cover some Microsoft solutions on the topic. And last, Sherry will cover solutions to accelerate SAP S for HANA migrations to Azure. Sherry, do you want to introduce yourself?
Yes, hi. My name is Sherry Yu. I'm a director of SAP Success Architect at SUSE.
And I'm Ralitza Deltcheva. I'm principal architect at Microsoft for SAP workloads on Azure. And I specialize in the area of high availability and disaster recovery.
Yeah, before we jump into the technical details, let's take a quick look on the SUSE Microsoft partnership.
Okay, so Microsoft Azure and SAP workloads. It's one of the clouds that has deep experience with running enterprise workloads. It offers significant cost savings. We take security very seriously. We know that it's super important for workloads like SAP, for instance, which run very critical business processes. It's a platform. It's a platform which offers a lot of uniquely tailored architectures for SAP workloads. And Sherry, do you want to take over from here?
Thank you. So SUSE has over 20 years collaboration history working with SAP as a technology partner. And the SUSE solution for SAP was the first available on Microsoft Azure. SUSE is a developer of the pacemaker-based HA solutions and provides very unique HA feature on Microsoft Azure. SUSE also provides solutions to automate, validate, and monitor the SAP landscape. SUSE has the largest SAP workload with over 130 worldwide benchmarks. And SUSE is also the reference platform for SAP Hack and RISE with SAP.
Okay, so as you heard, the topic for today is high availability and disaster recovery. So it's a question which comes up very frequently with customers and partners. Why invest in high availability solutions? And the first thought that comes to mind is to minimize unplanned downtime. And that's rightfully so, because no matter how much we plan and how much we try to eliminate incidents, incidents can happen. And this is when your high availability solution will kick in and help minimize the impact of such unplanned downtime. But I also want to talk today about the secondary benefit for implementing high availability solutions, which is frequently overlooked. So imagine the following situation. You have a database and you need to update the database software. Without high availability, what you need to do is incur a downtime which would be equal to the duration of updating the database software. So what happens if you have high availability implemented? You can employ a very different approach. Let's say it's a HANA database. You can patch the secondary. Then you can do a quick failover, and then you can patch the new secondary. So with such an approach, with high availability implemented, you can actually reduce the downtime for such maintenance activities down to just a few minutes. Another reason why customers and partners invest in high availability and disaster recovery is to protect their data. And if we elevate the conversation even further, the Uber goal eventually is to safeguard their business processes, because it's not only a matter of saving on technical downtimes, but at the end, the goal is to protect the critical business processes which run in the SAP system.
So there are various solutions to reduce unplanned downtime. The first one is the high availability for 24 by 7 systems. So SUSE's HA solution is based on the automated failover for HANA, NetWeaver, and S4 HANA. It supports on-prem, virtualized environment, private cloud, and also public cloud. So for HANA system, it's based on HANA system replication, and we support pacemaker-based automated failover solution for HANA system replication running in scale up and also running in scale out. And for each architecture, there are various scenarios to meet the business needs. And for NetWeaver and S4HANA, we provide SAP HA-interface certified HA solutions to support answer 1 and also answer 2. Recently, SUSE released a new architecture to simplify the file system structure. So it's called Simple Mount File System Solution. The last one is to enable proactive monitoring, so you can prevent issues when it first happens, and so to avoid cumulative errors that eventually cause the downtime. So for that, both SUSE and Microsoft work together to provide insights to the entire SAP landscape. So regarding the solutions to reduce planned downtime, first of all, as Ralitza mentioned, SUSE provides a rolling update to SAP HANA that run in a two-node cluster. And you update secondary first, then fail over, then update the prior primary. And it's a very efficient way to update HANA in the cluster, especially for the production environment. And the second solution is to reduce downtime after HANA reboot. It's based on the persistent memory technology. So Microsoft supports the Intel Optane based persistent memory based architecture. And with persistent memory, the reboot time that it takes after the HANA system reboot is dramatically reduced. The second one is to keep the ACP system secure by applying kernel light patching. And with SUSE's kernel light patching, customer can avoid reboot for up to 12 months. And the last one is to maintain a cluster and avoid a split brain. This is done through the HA interface certified solution. So when the assist admin maintains the applications running in the cluster through subcontrol or MMC, and the command can coordinate with cluster, and the cluster would know that this command is on purpose. So, for example, when the application server is stopped, cluster would not try to remediate. So regarding the HA solutions based on the pacemaker, SUSE is the innovation thought leader and the source of the expertise. SUSE develops the pacemaker-based solutions for HANA and also for NetWeaver and S4. So let's take a quick look at the solutions. So as mentioned, for HANA system replication-based HA solutions for scale up, SUSE now support performance optimized, cost optimized, active with a secondary read-only enabled, and also replication chain and multi-target system application. So for HANA sensor application running in pacemaker in the scale out architecture, SUSE supports performance optimized with or without standby nodes, and also performance optimized with secondary rate enabled. So right now we are also testing HANA sensor application running in scale out with multi-target tolerated. So ramp up phase already started. For ACP NetWeaver and as for HA solutions. And first of all, SUSE has developed the cluster connector that's being used in the HA-interface certification. And we support ANSA 1 and ANSA 2 based ASCS ERS HA solutions. Both are HA interface certified. And the simple mount structure is already supported on-prem. And the Microsoft has a plan to support this architecture on Azure.
Okay, so before we dive into the details and the portfolio for high availability reference architectures for SAP workloads on Azure, I just wanted to say that as we embark on releasing a new architecture, and it is true for the architectures which are already released, we always work in very close collaboration with the colleagues at SUSE, at SAP Engineering. So you can be assured that when you embark on implementing a reference architecture for SAP workloads on Azure, that will be also fully supported by SUSE. If we start first with the SAP application layer, we have a complete portfolio of reference architecture for high availability. What you see listed on the right-hand side are the documents, the publicly available documents for each one of the reference architectures, pretty much in chronological order. The very first one that we released quite a few years ago was relying on NFS DRBD cluster to service the SAP shared directories, which is, as you probably know, one of the single points of failure in SAP application reference architecture. Then as we moved on, we released two more reference architectures which rely on NFS as a service to offer a solution for the SAP shared directories. So if we look on the left-hand side, there are some components in each one of these architectures which are common. So no matter which one you choose to implement, one of the elements, one of the building blocks is going to be a pacemaker cluster for SAP ASCS ERS. No matter which one architecture you choose, you will need to have a load balancer for the SAP central services to provide a virtual IP for ASCS and ERS. You will need to have a supported StoneIt method in your cluster, and there are two that are supported on SLES. You can either go with an SBD or you can go with Azure Fence Agent, and obviously you need to have a compute layer deployed. Which means essentially your virtual machines to run SAP ASCS and ERS. Now then, the question is, what would be the difference between these three, between these reference architectures? And the difference is actually into how and what components services the SAP shared directories. By SAP shared directories, I'm referring to SAP M&T, I'm referring to USR SAP, ASCS, or ERS. Depending on the architecture, you either have an NFS cluster, which you build by yourself, you, the customer, build by yourself, or you can choose one of the reference architectures which relies on native NFS offering in Azure. And the two offerings are NFS on Azure NetApp files, or the other one is NFS on Azure files. So you might be wondering what's the difference between the two. They both offer ease of maintenance. You don't have to maintain and patch VMs for NFS cluster. It's very easy to implement. It's essentially can be done via configuring in the portal, or you can use APIs to deploy automatically. You can resize on the fly with either one of them. Probably one of the major differences comes into when we talk about the methods of replicating. With ANF, there isn't a synchronous replication across multiple availability zones in Azure. With NFS on Azure files, what you get is synchronous replication across all three availability zones within an Azure region. And last but not least, I want to point out that we also support multi-SID implementations for SAP Central Services. That was done, again, in a very tight collaboration with the engineering team in SUSE. And it was done in response from feedback from both large SAP customers and hosters who were looking for ways to optimize, to cost optimize their SAP implementations on Azure. Now, we talked about the SAP application layer and the portfolio of reference architectures that we have. Now, let's talk a little bit about SAP HANA. As you know, SAP HANA is one of the popular database solutions for SAP workloads. Again, we have a quite comprehensive portfolio. We support both HANA Scale Up and HANA Scale Out reference architectures. When we talk about HANA Scale Up, there are two reference architectures that are offered. One is the more generic reference architecture, which can be used by either using block storage or NFS mounted storage. The second one, which is also HANA Scale-Up architecture, it's specifically tailored towards implementation where HANA Shared is NFS mounted. And what this reference architecture offers is additional pacemaker configuration, which is capable of monitoring and detecting loss of access to NFS mounted HANA Shared. And with that, it can help to much quicker trigger a failover in a misfortunate event of such a loss of access. Now, if we talk about the HANA scale out reference architectures, we support both N plus M, the so-called N plus M, which is also known as scale out with standby. And we also support a full-blown scale-out reference architecture with HANA system replication and pacemaker. When it comes to choosing, when it comes down to choosing the right architecture for your scenario, there are a couple of questions which come very frequently from both customers and partners. So with scale out and with standby node, what you gain is ease of implementation. It's simpler to implement. However, in a case of a downtime, it will take longer for your application to recover fully to fully operational mode. If we talk about the HANA scale out with HSR and pacemaker reference architecture, you need to be aware that there is a bit of a more complexity in the configuration for such architecture. You do need to double up essentially on the compute layer, but what you gain from such architecture is a much faster failover. So when you're weighting in the pro and cons, it boils down to answering a couple of questions: how critical it is for your application to minimize the downtime, and what is the appetite to spend more in order to achieve this faster failover for HANA scale out. Now, when we also talk about SAP reference architectures on Azure, it would be important to be familiar with several constructs which are highly frequently utilized with SAP reference architectures. The first one, let's talk about when you deploy a virtual machine or your compute as a single instance. When you do that, you're essentially relying on the so-called service healing in order to recover the functionality of your application. What you would achieve in such a scenario would be a VM SLA at 99.9. And that's true if you deploy the VM with premium storage. Um, Relying on service healing is typically appropriate for non-critical, non-production SAP systems. When we talk about critical production SAP systems, the typical choice would be to deploy either in availability sets or across availability zones. When you deploy your compute layer, when you deploy your virtual machine in availability set, you achieve an SLA for the VM at 99.95%, and your application will be guarded from failures within an Azure data center. What you're also going to gain by deploying an availability set is that when updates roll through the Azure infrastructure or through the hypervisor, you have a guarantee that your virtual machines, which are distributed across update domains, they will not be impacted or they will not be patched at the same time. Now, the other construct, which is becoming more and more popular with SAP on Azure customers, is the construct of availability zones. When you deploy your virtual machines or your application across availability zones, you gain a protection from an entire data center failure, or entire zone failure. So while it is not something which happens frequently, as a matter of fact, it's almost unheard of and it happens very rarely, but for super critical SAP workloads, customers are more and more interested in deploying across availability zones. So this is one of the most popular constructs that we currently see with customers and partners. Again, when you deploy across availability zones, you're going to see a VM SLA of 99.99. And the next level, if we take it to the next level, if you want to protect your workload from not only an entire data center failure, but let's say a widespread regional disaster like widespread flooding or a hurricane or another natural disaster, then you would also need to think and you would need to implement a disaster recovery solution for your SAP application. A typical construct in some geographies, or actually in many geographies, would be to do the so-called true DR. In Azure, there is the concept of paired data centers. And if you rely on these paired regions, actually, I should say, then you have a guarantee that the data residency is at least 500 kilometers apart. I should say, if we come back to the availability zones conversation, that in some geographies, we see customers deploy disaster recovery across availability zones, and this is the so-called Metro DR. Although not officially recommended, it is certainly an option which customers choose to implement. And the one thing that you should be aware when you are employing the concept of Metro DR is that there is no guarantee for the distance between the different availability zones within a region. So just something to keep in mind. If we come back again to the availability zones topic, should mention that pay attention to the cross-zonal latency because it's not exactly the same in different Azure regions. Okay, and just very quickly, if I zoom in on one of the reference architectures which we released relatively recently, it is about the SAP application layer. It is It is high availability for ASCS, for SAP Central Services with NFS on Azure files. As mentioned earlier, what you gain from this reference architecture is that you can do a true cross-zonal deployment, and you have both compute and your storage aligned in this cross-zonal deployment. With NFS on Azure files, when you deploy the storage account, you have two options for data replication. LRS, which means 3 copies locally within a zone, or ZRS, which means that your data will be synchronously replicated in each one of the 3 availability zones within a region. And one other thing to point out when you implement, if you decide to implement this reference architecture, is that it's important to use private endpoint. That gives you two things. One is that the data exchanged between the SAP application and the shares will not leave the security boundaries of your virtual network. And two, in the very unlikely event of a complete zonal failure, you don't need to remount the shares. Your NFS sessions will be automatically transferred to a healthy availability zone. And with that, I want to turn back to Sherry to talk about the certified SAP application HA interface.
Yeah, yes. As I said in the previous slide, SUSE has worked with SAP on this HA interface certification. The backbone component, the cluster connector, is developed by SUSE based on the expertise. And regarding the benefit of this certification, is to boost the confidence for the customers using an SAP certified solution. And more importantly, it's a certified start and stop infrastructure within the HA setup, which means that it provides seamless operations for start, stop activities, especially during maintenance, and also provides a seamless operation for rolling kernel switch, things like that. The reason is when the sysadmin operate the SAP application servers through the SAP toolset, for example, subcontrol or MMC. And if you need to stop the application server that's managed by the cluster, and the activity needs to be collaborated with cluster. So that collaboration is done through this HA interface. So when you stop, for example, the ASS instance through that communication channel, cluster would know that this is on purpose. Then cluster would stand by and not try to start that instance. So this provides a easy way for sysadmin to perform maintenance on applications in running inside the cluster. And so there are various versions of certificates required by SAP. The NWHACLU 750 is based on NetWeaver 750, and the S4 HACLU 1.0 is based on S4 HANA above kernel 1809 or newer. So there are slight difference between these two. As mentioned, the first one, because it's based on NetWeaver, the databases that are supported include all the databases that's supported by NetWeaver. For example, SAP ASE, Oracle database, DB2, MaxDB, and also the HANA database. But for the S4 certification, because it's based on S4 HANA, so only HANA database 2.0 is supported. And the formal one, the NW one, is based on ANSA 1, and for that reason, only 2 node cluster is supported. But in S4 HANA 1809, it's ANSA 2 that's been supported. Because of the enhancement in ANSA 2, it's possible to run more than 2 nodes. So SUSE certification use the typical 3 node cluster. And we have detailed documentations on the certifications. So you're welcome to check SUSE website if you want to know the details. And as a summary, so HA is a very complex setup that requires a lot of learning and also skill set. So, in order to help our customers accelerate the migration to SAP S/4HANA, we have and also on Azure. So, we have developed joint solutions with Microsoft Azure. So, the first one is the automation. The Microsoft SAP Deployment Automation Framework is already released. It supports end-to-end SAP landscape deployment, including cluster configuration within the Azure cloud infrastructure. And it's based on SUSE's best practice and to speed up the provisioning and also reduce errors, especially the human errors. And it can reduce deployment time from weeks or months to days or even hours. And SUSE is a contributing partner to this project. And the second pillar is the validation. So a lot of times, even the customer use automation to deploy the SAP landscape, and very often customization needs to be done, and very often manually. So sometimes it may create some drift in the configuration. So in order to help customers, especially before go live, to identify those potential issues in the configuration, SUSE has released a project called the Trento. So Trento is developed based on also SUSE's best practice and also Azure's best practice. It provides checks onto the SAP landscape, especially the high availability clusters. Um, and there are two use cases. The first one is the pre-go live validation to ensure the quality. And after go live, in day two operations, especially after changes has been made in the SAP environment, you can also use it to validate the configuration to avoid deviation that may cause outage eventually. The last solution is monitoring. And as mentioned in the previous slide, proactive monitoring is a very powerful tool to help identify issues in early stage and avoid downtime. So Microsoft Azure Monitor for SAP is a native Azure service. It helps customers to gain insight into the SAP landscape, especially the HA clusters. And it can also help monitor the healthiness and fix issues before outage happens. The Azure Monitor for SAP HANA system application running in the cluster is co-developed with SUSE. So from the SUSE side, all the solutions that we have been mentioning in this presentation, from high availability to the Project Trento, are all part of the SLES for SAP applications. So it simplifies and strengthens the SAP deployment with robust solutions co-developed. Some solution is co-developed with Azure. So, for example, Trento also includes checks on the Azure cloud infrastructure based on the known issues and the solutions that we have discovered in the real time, in actual customer environment. And SLES for SAP applications is a SAP endorsed app and also available in the SAP store. This is the end of our presentation. If you have any question, please feel free to reach out to your representatives at SUSE and Microsoft Azure.